What's up, Clarity Coders? So I found this really cool project called Battlesnake. So what Battlesnake is you spin up a web server and then you code a bot to play this game of Snake where you're competing against others to try and survive the longest or complete challenges. Now, what I think is super cool is we have a really easy way to spin this up in minutes on Replit and host our own bot, and we can compete on the leaderboards and do challenges together. So what I'm going to show you today is how to spin up a Battlesnake instance on Replit, and then we're going to get our snake playing a random sort of move set here. Once we do that, we're going to go to the challenges and we're going to complete the 4 easy challenges by programming our snake to avoid walls and things like that. I'm going to be coding along with you guys line for line. So let's not waste any more time and jump right in. So you don't have to have any installation done because we're going to do this on Replit, but I am assuming some programming knowledge. But if you have none, I think you'll be able to follow along with this video. You might have some questions, but you can always jump in the Discord if you need any extra help. So from this main homepage, they have a really nice documentation page. I'm going to click View Docs, and then there's a quick start guide here. So let's go ahead and hit the quick start guide. And here it shows you how to create it with a free Replit account, which is what we're going to do. And how to customize your projects and different things like that. So what we're going to do is you can do any language you want. I'm going to do the Python one because that's what we do mostly on this channel. But if you like this video and want me to do it again in JavaScript or something like that, I'll do that as well. So let's click on Open Starter Project in Replit. You're going to have to sign up for a Replit account if you don't have one. Again, it's free, so this is going to be the quickest way to do it. You can also do it locally, but that's a little more involved and you have to do some dependencies and things like that. So if you want to follow along, sign up for Replit and then I'll meet you on the other side. So once you get signed into Replit, it should start cloning the project and you're going to come to a screen that looks like this where it's installing Flask and a couple other things. The great part for us is it's almost ready to run now. Like we can start up our bot and actually compete on the server and different things like that. So what we got here is our instance. You can see it's going to run server.py. What that's going to do is it's going to connect and get some data info back from us. And right here, you can see we can change some basic info about our snake. So in order to test this out, you could change your snake color here. See, we got a nice light pink here. I'll use that. There we go. So we've updated our snake. Then eventually all of our logic's going to be here in server.logic. But let's get our snake connected and at least see if we can see it in the challenges. So what I'm going to do is I'm going to go ahead and run this server. Now this server will fall asleep if you're not interacting with it. So if you're not playing Snake, you might have to restart it from time to time. I do have some codes for always on the Discord. So if you jump in the Discord, I should be able to provide you something that will let you keep this on 24/7, at least for a 4-month trial period or something like that. So what we need here, once you spin that up, what we need here is this URL here. This is what we're going to use to connect our snake. So then we can go back over to our Battlesnake page and we're going to create an account here. Go ahead, use your email, sign up, and I will meet you on the other side of this. So once you get signed up, you should come to this page that's showing your profile. We're going to go ahead and create a Battlesnake. You can name it whatever you want. This right now is a random snake, so I'm just going to call mine Random Snake. I'll paste that URL that we grabbed from our Replit instance. Pick your server and all that. You can give it tags. We can say it's Python based. Okay, and we can go ahead and save our snake. That's it. So we got our snake created. So now we can use challenges and it's going to use the logic in our snake to pick the move. So if I close out of these, minimize this. And for you guys, I'm going to turn up my font size a little bit. Hopefully that helps you see a little bit. So we're here inside the server_logic.py. So what you'll see is they've created some base functions to help us get started with writing our own snake. So they have an avoid head function, a choose move function, And that's it. So what our snake's doing right now is it's passed in a data dictionary. So from there, they're grabbing out information about the head of the snake and the body of the snake. They're setting up our possible moves, which are up, down, left, and right. Then they're calling the avoid neck function. So whichever way our neck is, it's making sure we don't move back into our own neck and lose from that. And then from the remaining moves, we're picking a random move to move our snake. So that's all it's doing right now. So to run this snake just in a generic game, we can go to play game. We can add in our battle snake by pushing the little plus button and then start game. And you'll notice in your console that it's playing the moves. So it says move 0. From all the valid options, we pick to go up. So if we progress, you can play and it'll run through all the turns, but if we progress 1, we should see our snake move up. Then move 1, we picked right from all the available options, so we moved right. Then we picked right again from all the available options. So you'll see it's moving to the right. So it's always orientated with our right and left here and up and down, not the snake's right and left and up and down. So, and then finally, it shows up, which hit that wall above, so then it lost. Okay, so that makes sense. So our snake does work. So if we look at some of the challenges that we're trying to attempt, we can see here we're trying to avoid the walls. We're trying to survive 100 turns without moving off the board. That makes sense. So if we look back at the arena here, so we can add in our battle snake to this challenge. We know it's not going to complete it, but if we look at the arena here, we can see one thing. Well, it's dynamic. The last one we did was 11 by 11, and this one is 5 by 5. So we want to code it in a dynamic way so it always performs well no matter how big the environment is. So the first thing that we can start looking at is that data packet itself. If we go back to our code, remember they're passing in a data dictionary of items, and then we're pulling information off about the head and the body and different things like that. Well, I'm very interested in knowing the size of the board right away too. So in order to check some of this out, let's take another look at the docs. So to find this, I went to Battle Snake example move. I Googled that. And you can see here that I got a sample move request. So when we move, this is the information that's coming back in that data packet. So you can see in the code right now, they're using data U. So on this first level, you can see there's game, turn, board, hazard, snakes, U. So it's grabbing out U, and then it's grabbing out the information in the head field right down here. And it's storing that in the variable myHead. Then it's also creating a variable called myBody, and it's doing the same thing. It's going to U and then grabbing out the body information. So we can add more information into this choose move function. The two that I am very interested in adding are the height and the width of the board itself. So I'm going to add two more variables. I'm going to say board underscore height equals. I'm going to data, and if you look on that sample move request, we can go inside board. And then there's a height key. So now we should have the board height. Then there's also a board width. So we can set that equal to data, and we can use board again, and they have a width key. So now we should have information for our board height and our board width. Now we're going to come back to the avoid neck function, and we're going to make it avoid our body altogether, not just the neck for when our snake gets bigger. But I like the setup here. So it's giving all the possible moves, and then it's avoiding that based on where our moves are. But one thing I think would be helpful is to adjust this so we know where the next position will be as well. So for example, if we move up, we know that our Y is actually going to increase. If we move left, our x is going to decrease. If we move right, our x is going to increase, and so on and so forth. And just to clarify that a little bit, typically I would consider this square right here 0, 0. Well, on these boards, that is not the case. 0, 0 is in the bottom left here. So our y is going to increase as we go up, and our x is going to increase as we go towards the right. So one of the things we can do out of the gate is change these possible moves, and we also want to update where we would be if we completed this move, because then we can test if it's a valid move and different things like that. So what I want to do is kind of foresee the future a little bit. If I'm going to move up, then where will I be on the next turn? So I'm actually going to erase the list from above, and I'm going to create a new dictionary of possible moves. So we're going to use curly brackets here. And my first move is going to be up. So for my up move, I know that my new x-axis, so I'm going to use a lowercase x, is going to be wherever my head is now on the x-axis with no change, right? If I move up on the board, my x position isn't going to change at all. What about my y position? Well, my head y is where it currently is at, and if I move up, my new y location is going to be increased by 1 because we're moving our snake up. Now this is a little work up front, but it's going to make our life so much easier down the road, so hang with me here. So if we move down, what's going to change? Well, our x-axis isn't going to change at all, right? So our x-axis is going to stay exactly the same, and our y-axis is going to decrease by 1. Comma there is optional, but we'll leave it. So what's my next key? I can move. Oops, we forgot to subtract 1. I said it, but I didn't actually do it. So our y will actually decrease by 1. So our next key is left. And another dictionary inside of that, just like all the others. We're going to say my_head. Now this is changing, right? So my head x now, if I move 1 to the left, we're going to decrease our x-axis by 1. And now with these sideways movements, our y-axis is not going to change. And same with our right movement. Make it a dictionary. We'll say our x-axis, my_head, wherever it was already, and then we're going to add 1 to that, and that's going to be our new location if we were to move right. And then y, same thing, my_head, y, and this one does not change. So now we know where each of our possible moves would be if we actually made those moves. So that's perfect. So now we can pass all this information into our functions. So our avoid neck probably isn't going to work anymore because we redid it a little bit, but that's okay. Instead of avoiding the walls, let's actually tackle that first since it's already built here. Well, I don't want to really avoid my neck. I just want to avoid my entire body. So if our snake gets bigger, I still don't want it to turn into itself. We never want our snake to pick a move that's going to cause it to lose unless it absolutely has to. So we're going to change this function name to avoid my body to stay consistent. And then up here, we can change this to avoid my body. And we're not going to pass in the my head variable anymore. So I'm going to delete that. And we're just going to pass in my body and the possible moves. Now we've changed this as well, so I'm going to actually clear this out. We can put that back in. But I'm going to just make it my body and then the possible moves. Now, if you show errors and I don't or anything like that, make sure you're double checking all of the formatting, all the parentheses. Make sure you're using a curly bracket where I use a curly bracket, so on and so forth. So now we can change this doc string when we get it. We're not going to have my head anymore. We don't need that. So we're just going to pass in my body, the possible moves, and we're still going to return a list of the remaining possible moves. Okay, so from my body, how are we going to know what the safe moves are? Well, we know our left, right, up, down, all that. We know where they're going to end up being if we would happen to move there, right? So we know if we move up where it will be, if we move down where it will be, and that sort of thing. So if we look back at this sample move packet, you'll see that our body has inside of it coordinates. So this is where our body is. And you'll notice it contains the head as well. You'll notice our head is at 0, 0, and that does show up in my body. So we don't have to test for that explicitly. So what we're going to do, we're going to look at each movement. So say we're going to look at up. If we're at 0, 0, up would put us at 0, 1. So what we're going to do is we're going to say, is 0 on the x-axis and 1 on the y-axis somewhere that our snake is already at? If it is, don't move there. And you'll see in this example, it's not in there. So we would say that's still a possible move because we're not going to run into ourselves. All right, so forgive me a little bit. I'm probably not going to code this in the most efficient way possible, but I'm going to make it as understandable as possible. So we're going to have a list where I keep the moves that I want to remove. So remember, from our possible moves right now, we have left, right, up, and down. So I'm going to make sure that I keep track of the ones that are going to run into our own snake. So what I want to do is I want to iterate through all of our possible moves. So I'm going to say for direction and location in possible moves dot items, we're going to do some stuff. So what am I doing here? So I'm doing possible underscore moves dot items. So what happens is that pulls this into direction. So the direction variable is going to hold up the first time it runs, down the second time it runs, left the third time it runs, and right the fourth time it runs. Then the location variable is going to hold this dictionary, which consists of x, y coordinates, which is exactly what my body has. So I can say for direction location in the items, and then on our next line here, we're going to say if our location is in my underscore body. So if we find out where we're moving to, our snake already has a piece of its body in that location. We don't want to move there, right? So we're going to do remove.append. And then we can append whatever direction is no longer valid. So what this is going to do, it's going to iterate through all of our remaining moves, and it's going to add anywhere we can't move to without losing to our remove list. Then after that's over, we can do for direction in remove, delete the possible move from our dictionary. So if left ended up getting added to our remove list, we're going to go through that list, no matter if there's 1, 2, 3, or 4, and we're going to delete that from our dictionary. So what it's going to return back is the remaining valid moves that won't cause us to lose, right? So if our snake is already in the square to the left of us, it'll delete out that move and not leave an option to move there. So we've adjusted this function, so now it shouldn't avoid our neck, it should avoid our whole body. So that's pretty cool. So if we run this, let's go ahead and run it just to see if we have any errors or anything like that. Our snake's not going to perform better because it doesn't know how to detect walls yet, so it's probably still going to run into a wall. You'll see that our server is running again, so we can go back to our Battle Snake training program and we can go to retry challenge, and it should automatically update our snake as well. So if we retry this, remember, we're just looking to, yep, you can see here we got an error. So avoid my body takes 2 positional arguments, but 3 were given. So if we go down to where we call it, we called avoid my body. Remember, we updated it above so we don't have to pass in my head anymore. So let's delete that and save it. You'll notice that the server restarted on its own, so it should take care of itself. If you have issues, stop and rerun it and try that. So now that we fixed that error, we can go ahead and retry the challenge. We're not gonna pass the challenge. We're just trying to see if we can get through it, okay? So it says we got a key error. Let's check that out. Key error of 0. On 93. Ooh, so remember, we changed how we're storing our moves here. So now we need to create a list. It's grabbing a random choice from our moves, and we didn't update that after we changed how our moves look. So our moves were just a list before, and we're not doing that anymore. We're overriding it, so you don't have to comment this out, but I will. So we got that commented out, but at the end of this, we need to make that same list so we can choose a random move again. But right now we have a dictionary instead. So remember, our list of moves is, we can actually overwrite that variable. Our list of moves is a dictionary right now. So we're going to take whatever possible moves were left, and we want to get out the keys. So remember, the keys are left, right, up, or down. And then all we have to do is turn this into a list. So basically, this is going to give it back just a simple list of all the possible choices, if there's a valid choice. And we can even do some error checking here. So we could say if the length of our possible underscore moves equals 0, because remember, eventually maybe we don't have a legal move. Maybe we're gonna lose, right? So if our length of our possible moves is greater than 0, we want to choose one of those moves. Otherwise, we know we're gonna lose, because if we don't have any valid moves left, we can just set move equal to up, and we can print going to lose, because we know there was no valid ones left. Okay, so let's go ahead and run this. Hopefully we at least can get it to run again. We can go back to our challenge and we can retry our challenge. And you'll notice that our code at least works again. So it did hit the wall, but that's okay, right? We knew it was going to probably hit a wall. We haven't taught it how to avoid the walls, but we did avoid ourselves. So right now it's making a total random move, but it's cutting out anything that would make it run into itself for a loss. So the only thing we have left to do to make it complete this first challenge is to avoid the walls as well. So we pass into the function to avoid my body. Let's also pass into a function in the exact same way to avoid all the walls. Now that function doesn't exist, so this is going to cause an error, as you can imagine. So what we need to decide if we how to avoid the walls, the only thing we really need is the board width, the board height, and the possible moves. So you remember up here, we set the board height and the board width. So we should have that information. And now we just need to create the function to avoid the walls. And it's going to be really easy because of how we coded our possible moves. So that's nice. Okay, so we're going to create a new function here. We're going to call it avoid walls. And we're going to pass in what we said we were going to pass in. So we're going to pass in board width, board height, and the possible moves. Then we're going to do something extremely similar to what we did before. So we're going to create a list of moves that we're going to remove after we finish iterating through our possible choices. We're going to say for direction, location in possible moves.items, doing the exact same thing as before. And we're going to see if our X or Y is out of range. Okay, so we're going to create two Boolean values. So these are going to be true or false. So the first one is going to be, is our X out of range for this move? So is our X out of range for this move? I'm going to put it inside parentheses. I'm going to say our location 0 value. Nope. I'm going to say our location X value. Is it less than 0? So does this move put us off the board to the left? So if it's -1, we know that's not valid. Or is our location of our X coordinate equal to the board height? So remember, we start our indexing at 0. But if the width of our board is 11, that means if our X has a location of 11, it's actually off the board, because our valid positions on a width 11 board are going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 for our 11 spots. There's no actual 11 spot. So if it's equal to our board width, not height, it is also invalid. So if either of those, I did an OR here, so if either of those return true, then our X is out of range. So what about our Y out of range? So our Y out of range, we're going to do something similar. So we're going to say, I'm just going to copy this, paste it in. We're going to say if our Y is less than 0, or if our Y is equal to the board height, then our Y value is out of range. So now we can test if either of these are true. So if X is out of range or our Y is out of range, we want to remove that item. So we're going to append it to our remove list, the direction. Easy, right? So now that we have that done, we can go ahead and delete the possible moves afterwards. So if we slide up, we're going to do the exact same for loop we did here. Now make sure your indentation matters. So make sure everything is lined up just like mine is. So we're on the same level as this for loop here. So we're going to say for direction in remove, delete that possible move. So if it's invalid. And then we're going to return our possible moves. Simple as that. So let's save it. And now we should have eliminated all the moves that are going to hit a wall as well. Now in this level, this challenge, that should be enough because our snake's never going to grow because there was no food and everything like that. So it should survive until it runs out of health. So let's go ahead and run this. You'll see our server has started up. We can go back to our challenge and let's retry the challenge. And we should win this time. So we should survive 100 turns. You'll notice that the snake does have health. That's going to come into play later. So we're going to get to that. But right now we're not worried about health. We're just trying to survive 100 turns. And we completed the challenge. All right, so we can go ahead and go to the next challenge. This is called avoiding yourself. So we should have this one beat already too, right? We got it coded in there to avoid the snake altogether. Now we're not making any sort of logical movements. We're literally just taking random movements. But it is smart enough to avoid anything that will cause it to lose. And you'll notice the board size increased and it still works. That's because we programmed everything dynamically. So it doesn't matter how big or small the board is, our snake should still follow its rules. So this one we have an issue, right? We're trying to avoid the other battle snakes, and you'll see we lost right away. Now with what we've coded so far, you'll see our snake started right here in the middle, and it picked to go down. So it would have hit this snake and lost. So our battle snake loses if we run into the side of another snake, but right now we haven't coded any way of our snake knowing where the other battle snakes are. So if we look at the sample move request again, you'll see that we can look at the other snakes. So there is some information called snakes. Then inside of the snakes, it has multiple instances. So we're going to have to do this dynamically. So if there's 1, 2, 3 snakes, we don't care. We want to check to make sure where we're moving is not going to hit the body of another snake. So let's go back to our code real quick. We need to get some other information. So to stay consistent, I'm going to add that in the information that I'm getting above. I'm going to call it snakes, and I'm going to set snakes equal to data, and then we can pass in snakes. So this should get us the information we need to avoid the snakes. And we'll add this function down below. So we also want to remove any, and you can see we're really cutting down our move choices here. We want to remove any move that's going to hit another snake as well. So let's create a function called avoid snakes. So what information do we need to avoid the snakes? Well, we need the information about the snakes, and we need whatever possible moves we have left. So whatever valid moves we still have, we want to pass that in. And then we can create our function from above. So we have an avoid my body, we have an avoid walls, and now we can create def avoid snakes. We're going to pass in our snakes and our possible moves. So this is a little tricky. We're going to have to nest some for loops, but our structure is going to stay the same. So we're going to say for, and to stay consistent, our avoid walls one, we should have a return possible moves. So we're going to leave our remove list here just like we did before, and we're going to keep this same kind of final pattern. So after we're done, we're going to delete all the moves that are going to cause us an issue with the other snakes, and then we're going to return the possible moves. So that stays the same. And make sure, again, the indentation is right here. So the one difference is we want to grab an individual snake from our list of snakes, because we're going to have to test each one. Then we're going to say our classic for direction, location, in possible moves.items. You're probably getting good at this. We want to see if our location is in the current snake's body. So we're basically doing the same thing we did with our body. Now this is just going to be for that one snake. If it is, remove that direction from our choices. So it's going to do each direction for the first snake. Then it's going to go back to the for loop and see, is there any more snakes? Yes. Then it's going to do all the possible moves for that snake, and it's going to keep a running list of all the directions we need to remove. Then for that direction in remove, we're going to delete that possible move. Now I'm not sure if this is going to cause an issue if one of them wants to remove left a couple times or something like that. So to make sure there's no duplicates in remove, because I think if we try to remove it and then we can turn this into a set. So what a set does is a set is going to remove any duplicate. So I just want to make sure we're not trying to delete left multiple times and causing a key error because it doesn't exist anymore. So let's try that. I'm not totally sure if that's going to work, but that's the fun of this. We can just try it. So we're going to run that, and we should have set everything up because we're calling the function and we're grabbing out all of our stuff. So let's go back to our challenge. And we can retry this challenge. And you'll see that we had a key error of snakes on line 78. Ooh, so going back to our move packet, I got it wrong. Okay, you'll notice, see how board is on the first line here, and then inside of board, we have snakes. So I actually need to reach inside the board first, and that will grab us out the snake. Then we can grab out snakes. Okay, so let's run that again, and we can retry our challenge. Look at our little guy go. All right. So you'll notice now he's avoiding the other snakes. Perfect. And we completed our challenge. So let's go ahead and try our next challenge. We got one more left here, and we can wrap up this intro video. So right now, you'll see that we are training to find food. So we need to survive 250 turns. So for the first time, you'll notice our health coming into play here. So we can't beat this challenge if we don't find the food. Now our issue is our snake behaves completely randomly, except it avoids killing itself. So we're probably not going to find the food, and we're not going to survive 250 turns. So we want to add our first bit of logic to teach the snake to move in some sort of an intelligent way, at least when it has the opportunity. So what I want to do is find the closest food to our snake and try to improve its position towards that food. Okay, so let's get our snake set up so we can find some food. So what we want to do, I'm going back to my code here, is we want to create another function to find food. So I'm going to slide down the code here, and we will look at our functions. This stuff all came just when we cloned the project, so I'm going to delete that. So let's find a target. So there could be multiple instances of food on the screen. So we want to make sure that we're heading towards the closest one always. So we could just look at the first one, whatever the first food was, on the request packet, but I want to make sure that we're getting the closest one. So I'm going to call this function get underscore target underscore close. And I'm going to pass in my head and the foods. So we need to define the foods in our information. So we gather information up here. We grabbed snakes. Let's take a look and see where food is. So you'll see in the same request packet, we got board, and then we can go inside of foods. And as you can imagine, it is a set of locations on the board for food. If it has 3 locations, that means there's 3 instances of food on the map. So let's create our foods variable. We'll say foods equals data. We'll pass in the board, and then we'll pass in food, singular there. So this is our foods. Passing into our get target. So now let's create a get close target function. We're passing in foods and my underscore head. So we're going to import a library above to make this easy. We're going to make a tree, and then we're going to search for the closest result to our head's location, and we'll move towards that food. So from SciPy import spatial. Okay, now we can create our tree. So we're going to go back down to get close target. And now I'm doubting, did I call it get close target? Let's see, what did we name it? Get target close. Let's copy that. So we're doing get underscore target underscore close. Okay, so what we need to do is we need to get all the coordinates of the food in a list, and then we'll pass it into our tree, and it'll handle that, and then we can query that tree to get the best result for which food we should move towards. So let's say coordinates equals, and we'll just create a blank list. And then I'm also going to return none if we don't have any food. So if the length of foods equals 0, we'll return none from the function. So if it returns none, that means there's no food, so there's obviously no closest food to move towards. So we're going to say for food in foods, coordinates equal coordinates dot append. We can append the food x coordinate and the food y coordinate. Now this library, they did a great job. So everything's pretty consistent with how it's named and different things like that. That's why this is so easy to do. So we got food x. Oops, we need an extra pair. So we're actually passing in a tuple here. We have an extra bracket. Oh, okay. Missing a bracket here. We need one more parenthesis. So we're doing coordinates dot append. That's our append function. So the two outside parentheses are what we're appending, and we're appending one tuple with the x value and the y value. So it should create a list of all coordinates of all food using this for loop. And then we can create our tree. Spatial dot kd tree. We'll pass in all of our coordinates for our food. Now we can query that tree to get the closest result to us. So we can do tree dot query. And what are we going to query? We're going to pass in our x location and our y location as a tuple. So I'm doing square brackets and then a parenthesis, and then we'll do my underscore head x coordinate, comma, my underscore head y coordinate. Now this result's going to come back with two things. It's going to come back with a distance from that, which I don't really care about. It's just giving me the smallest distance is the first one, or is the result. So what I'm really interested is at the second index. So I'm going to actually do 1 because it's 0, 1 for the indexing. So after this whole result here, I'm going to grab out the first index. So that's a little messy, but make sure that you have the same parenthesis setup that I have and all of that to make sure you're grabbing out the correct results here. Now that's an index. So with that index, we know which food is closest. So I can say foods, square brackets, results at the 0 index. And that should give us the closest result to our food and grab out those coordinates. So this is going to return a tuple that has the coordinates that we want to move towards. Awesome. So if we slide down here, now we got a target, but we're still picking random moves. We're not picking a move towards our target if we have more than one. So what I'm going to do here is in this top if statement, what we want to do is we want to try and make an intelligent move if we have some choices here. So if we have no possible moves already, we know we're going to, if there's no possible moves left, we're going to lose. Our snake's already calculated we're going to lose. That's going to stay the same. So we want to try and get a move that isn't random. So if we have more than one possible moves, let's select a move by moving towards our target. And this is only if target is not none. With capital N. So if our target's not none, let's try and move towards that target. Else, we can just select a random move from our possible moves. So either way, we should get a move. So move target. What do we need to move towards our target? We got our possible moves because we need to know what moves we should be choosing from. So now we're hoping that there's multiple moves left and we're going to pick the best move out of here. We'll see where my head is and we need to know where our target is. So now we can slide up and create that function, which was move target. I'm pretty sure I already have forgotten. Move underscore target. We said possible moves. My underscore head. And our target. Okay. Now this one's a little more involved, but we know that we want to get our current X and Y distance from the target. So based on where our head is right now, how close are we to the target? And then we need to check our possible moves and see if any of those bring us closer to the target. So let's try that. So what we're going to do is we're going to get our distance. This is our current distance to the X coordinate of our target. So we're going to say my underscore head X, which is a string, minus our target X. Now, this could be positive or negative, so we want to get the absolute value. I always want this to be a positive value. And then we'll get the distance we are away on our y-axis. So we can copy this. I'll change this to y, and this to y. So then we can do our classic move that we're used to at this point. We can say for direction, location, in possible underscore moves dot items. We need to create the comparison distances here. So I can say new underscore distance X equals, we're going to do an absolute value again. We can take our location X, so this is if we decided to take this move, minus our target X. And then we're going to do the same thing for Y. So new distance, copy and paste in a little bit here. Y, Y, and Y. Oops, and up here I said possibles. This is possible moves. Okay. So now we can compare all these. So if our new underscore distance X is less than distance X, so if our new distance X is less than our distance X, so if we got closer on the X axis, or if our new distance Y is less than distance underscore Y. So if either of those are true, let's return this direction. Now remember, this is going to be our move. So let's say we get through all these. So now look, I'm on the same level as the for loop again. So let's say we get through all these moves and we never return a direction. So what we're saying then is none of our moves are really better than the other at moving towards that target. So all we're going to do is return a random move. So I can turn our possible underscore moves dot keys. So I'm going to turn that into a list and I'm going to return the first move. I don't really care what move because we've determined that none of them are really better. Okay, so we got that done. Let's slide down and double check this one more time. So if we have a possible move, at least one possible move, and if we have a target, then we're going to try and move towards that target. If we don't, we're just going to make a random choice. If we don't have any possible moves, we're going to move up, which we know is going to kill our snake. All right, let's run this. No errors out of the gate, so that's kind of cool. So we're still in our challenge. So we're in the finding food challenge. I'm going to go ahead and retry this challenge. I shouldn't have to reload or anything like that. And you'll see the list attribute has no attribute item. So this is on line 82. Let's see where we're calling this move to the target. Yes, so we are changing this into a list. So let's grab this line here where we change possible moves into a list. Actually, we shouldn't have named it that. That was kind of bad anyways. So if we don't have, oops, I didn't even say that. So we actually need to do it here. So if we need to get a random move, we need to change our possible moves into a list here. So list moves dot keys. Okay. So now when we're sending in our full dictionary here, so that should be good. If we need to choose a random one, we'll create a list here for it to pick from. I'm going to save that, rerun it, and retry my challenge here. Okay. You'll see here, it looks like it is heading towards the food. So hopefully it will survive. Hopefully it doesn't kill itself. Now it's not making any smart decisions like doubling down or anything like that, so it might trap itself in different spots, as we'll probably see here coming up, but hopefully we can at least get to 250 without it doing that. Because now when there's no food on the screen, remember, it's just completely random. All right, and we did it. So we got started and spun up in Battlesnake today. Oh look, we're on the website. That was my one from yesterday when I was playing around with it. It was the same code. We got through all the challenges and we're able to successfully complete at least these beginner ones here, the training program. Let me know if you want to see more of these videos. I think it's fun to play around with, so I'd like to create a couple more bots and maybe try and do this solo survival and even the battle arena. So let me know in the comments if you like these videos. Hopefully you got your snake working. If not, jump into the Discord and we can help you out there. And until next time, keep coding.